Hello. We'll do these learning checks about once a module. You can take them on lab day or after you complete the lab. And it's just a check to see if you're ready to then continue on and take the test, or if you need to go back and do some more review and go over your quiz problems and make sure they're 100% correct. So the best way to do this is once I read the problem, hit pause and then complete that work as best you can on your own. Hit unpause if you get stuck, watch a little bit, and then just try to see how much you can do on your own. And then use the video to correct it. Some of these will also have quizzes, so questions will pop up. Just answer the question. And if you like your score when you get to the end, hit submit, and then it'll record that score to Canvas if it is a graded assignment. Okay. So Sam does a warm up of 200 feet at 2 meters per second, then accelerates at 0.25 meters per second squared for 50 meters, and finally stays at that new pace for the remainder of the 400-meter run. And how fast did they run? So you can hit pause if you already know how to find your formulas and you have your formula sheet, and good luck. Otherwise, we'll start to go through this problem. So I am going to bring up my formula sheet here, and my conversion 1 meter is 3.28 feet, because remember, everything has to be comparing apples to apples. And that's going to give us just a little bit of idea of what's going on. So remember, my givens are, I'm going to be circling my knowns. 200 feet, that's a distance that they're going. At 2 meters per second, that's a velocity. They didn't give me a direction, so technically it's a speed, but if you notice when you look at the formula sheet, we are going to be going based on V for velocity. And accelerates at 0.25 meters per second for 50 meters, so that's a distance, and finally stays at that new pace for the remainder of the 400. So I am going to have to use some subtraction here to find out what that distance is going to be. Right. And what do I want to find? How fast did they run? So I want to find their average velocity, because I want to know how fast they ran over the entire 400 meters. Okay. So I underlined my unknown. And then I got to think about what equations do I need. So I'm now on the E part of the guess. What equations do they need? Okay, so I know I'm going to need average velocity here. That line over the top is going to tell me that that is the average velocity. That is going to be my final answer. What is my distance here going to be? It's going to be 400. And do we know a time yet? Nope, that is what we're going to be figuring out as we go along. And maybe we'll end up not needing this equation, but we definitely are thinking about that this one is probably going to be a viable equation. So now let's break it down. So sometimes it helps when you get to this part that you draw a little sketch of what's going on. Okay, so if you're like, I can't quite picture that, then draw a sketch. Okay, so we have our start. And we have our end. And we know how long is that? Even though it's a circular track, the amount that they're going to be running there is going to be 400 meters. Okay, and we're going to call this, we're going to go by distance here and not displacement. So I mean, you could sit there and say, all right, so their average velocity is 0 because they actually had no change in distance. But we do want to figure out what's actually going on in this case. So we are going to, and it doesn't say it's necessarily a circular track, so we're going to go and assume it's 400 in the straight direction that way. Okay, so the first 200 feet, we were at 2 meters per second. Okay, and maybe I should convert that right now so that I know what that is. 200 feet over 1, and I'm going from feet to meters, and there's 3.28 feet in 1 meter. So 200 divided by 3.28, going to give me 60.9756 meters. Now in physics, you'll notice we're not as stuck on significant figures here. So you could round up to 1 decimal place, which actually I can't do here. So I'm just going to round up. So the first 61 meters are at 2 meters per second. Okay, and then what happens? Now for the next 50 meters. So the next 50 meters, we accelerated 0.25 meters per second. Okay, so for every second we traveled, we were increasing our time, 0.25 meters for every second. Is there a formula that can help us out here? Go look at those formulas. Right, so what do I have? I have an acceleration, which would be the change in velocity over the time. I do not have how much time that one is, so that's not going to help us at this point. Okay, I have a velocity final, velocity initial, acceleration. Do I know my velocity initial? That's the velocity that we're starting with. So that's 2 meters per second. And in fact, we might end up coming back and needing this equation again for the final if we don't get enough times out of our situation. And our acceleration, 0.25 meters per second squared. And nope, guess what? We don't have that time yet, right? So we have these guys, but we don't have a time. So what else do we have? We have a distance, okay? So our distance that we traveled was 15 meters because we're only talking about this inside segment here, and that segment's 50 meters. Velocity initial, 2 meters per second. Time, acceleration, 0.25, and time. So we do not have enough for that one. How about this guy down here at the bottom? Okay, velocity initial, we have that as a 2. Acceleration, 0.25, and a distance of 50. So if at first you have too many variables left over, just keep working until you find that. So for this middle segment, we're going to use velocity final squared is equal to velocity initial squared plus 2AD. We don't know my velocity final squared, so that's going to stay exactly like it is. My velocity initial is 2 meters per second. That's going to be squared plus 2 times the acceleration, 0.25, times the distance of 50. So 2 times 50, that part's equal to 25. 2 squared is equal to 4. So velocity final squared is equal to 29. And I'm going to take the square root of both sides. So I'm going to find my velocity final at the end of this is going to be 5.385. So I'm just going to call that 5.4. So we're going to end up at 5.4 meters per second at the end of this one. Okay. And then we're at that new pace for the remainder of that time. So what we've had 61 meters and 50 meters. So that's 111 meters. And so there are 289 meters left for that third segment where they are going to be doing what? 5.4 meters per second because their pace remained constant. They stayed at that pace for that time. All right, so how fast did they run overall? So we have 2 meters per second for 61 meters. We had between 2 meters per second to 5.4 meters per second. And we did that for 50 meters. And then we have 5.4 meters per second. And we did that for 289 meters. So could we go back and figure out the times for each one, and then we could plug it into that average velocity equation? So you could do that, or you could do proportions. It's really, honestly, whatever you are comfortable with for figuring it out. So if we have an average velocity of 2 and 61 meters, then our time is going to be 61 over 2. That's going to be 30.5 seconds. All right, and so that is our first segment, took 30.5 seconds. Our second one, we don't have an average velocity, so I can't use that. So what other equations down here could I use? Let's clear off all these ones that we checked before. I need to get a time this time, and I know my acceleration, and I know my initial velocity. So I know my acceleration, I know my change in velocity, so I could use that one to find the time. I know my velocity final and my velocity initial and my acceleration, so I could use this one to find my time. I know my distance, my velocity initial, my acceleration, so I could use this one to find my time, but that one's going to be difficult. I can look at it right there. I'm going to need to use factoring or Pythagorean theorem. So even though I could, I'm not going to. Okay, and this one down here doesn't have time, so that's not going to be helpful. So could I use either ones of these? Yep, because I know both of those things. I know my acceleration is 0.25. And I know my velocity final was 5.4. And I know my velocity initial was 2.0, or just 2. And then I'm going to again solve for time. And I'm going to get 13.6 seconds for that one. Okay, so I accelerated for 13.6 seconds. And then the last one, okay, I have a velocity of 5.4. And I have a distance of 289. What is my time? 289 divided by 5.4, 53.5 seconds. So what is my total time? 53.5 plus 13.6 plus 30.5. My total time is 97.6 seconds. Meters per second. Okay, so that is what I want to be keeping it in. For SI units for physics, you are typically going to have your velocity or speeds in meters per second. 400 divided by 97.6, and that gives me 4.1 meters per second. And again, most of the time in Canvas, as long as you're reporting to that 1 decimal place, you are going to be exact enough in your answer. If you ever get one wrong and you can't find your error after you've looked at the quiz, you can always send me an email or put a note in the feedback. I can't find my error. Here's my work. And then I can say, oh, the computer just rounded differently or whatever. And I'll often give you points back if it was just a rounding error in that case. So that is the first one. What is the second one? Problem number 2. Oh, I guess there's just one on this one. All right, so that actually means we're all the way done. Sorry, there is no problem number 2 for this guy. So you are done. Just make sure if it was a video quiz where you answered questions as you went along that you wait to the end, hit submit, or else it will not record your grade to Canvas and you'll have to start all over again. And have a great day.